Happy Monday morning, guys. Hopefully your weekend went well, and you have a nice short week this week, only 2 days of class that we're going to be doing. Today we're going to be doing systems of equations still, only this time we're kind of stepping it up a little bit. Now, the stuff we learned last week technically is review from middle school. Okay, whether you remember it or not, you were taught it if you went to Janesville. Now, the stuff we learned this week is going to take the new equations that we learned this year, quadratics, which are parabolas, anything with an x squared in the equation, and we're going to apply it to the elimination and substitution processes. Now, I'm not going to lie, it's a little bit trickier. It's quite a few more steps than the other stuff we were doing last week. It's not necessarily going to be as quick and easy for some of you because it's not as much review. You are still capable of doing it though, so don't give up. But just realize that if you get stuck, you are not the only one who's struggling. So raise your hand, rewind the video, listen to it again if you need to. Do what you need to do, but make sure you understand it. So up at the top of your page, these are the 4 blanks that we are going to fill in. Now what they're saying is that when I have a quadratic, which is a parabola, the U-shaped graph, and I have a line, which is a linear, right here, they can cross in a couple different ways, all right? So one of them is that they can cross and have 2 solutions, which is what we have here. It's crossing at this point and this point, so those are 2 different solutions. Okay, now the other way, let me get rid of the red line, is we could have where it only hits it at one point, and that would be 1 solution. So that's the second option that we could have, is where it crosses at exactly that one point, and you can see the arrows are making it go upward, so it's never going to hit that line ever again. The third way it could happen is if they never cross. See how the parabola is going up? There's nothing that's going to go down and hit the line, and no matter what way I do the line, it's never going to cross, so that's no real solution. That's whenever you get imaginary numbers in your equation, so be careful of those I's. Okay, be careful of the imaginary numbers, because that means it's not a real solution. You have to put the word real. There is technically an imaginary solution to all of these, but not necessarily a real one. And then infinite would be where it overlaps, kind of like the last time we talked about. So if I have a red parabola that overlaps this black one, they're obviously going to have the same points for infinity. So that's where you get the infinitely many solutions. All right, quick refresher on our ways that we can solve quadratics. Remember, if I have x squared plus 5x minus 6, I could factor it, I could complete the square, I could square root it possibly after I do complete the square, and I could use quadratic formula. You always want to start with factoring every time because that's the easiest. If you can't do that, then jump to one of the other ones, all right? So first equation. Now we talked about last week on Friday that you may not always be able to do substitution or elimination for every single problem. I know a lot of you liked elimination better. Unfortunately for these ones, you pretty much have to use substitution. So whenever you see y equals and then the equation, then you're going to have to do substitution. So for ours, if we take a look at this, this is definitely not an elimination problem. I can't get rid of the x squared because there's no second x squared. The x's are going to be a pain to get rid of, and then I'd still have the y's with the x squared. It's just not going to work. So I'm instead going to substitute 5x plus 6 and put it in place of the y down here. So I have 5x plus 6 equals x squared plus 4x plus 4. Now, quadratics are going to be a little bit weird because it's a bit counterintuitive. We're used to trying to get all of the x's on one side and all the numbers on the other side. However, we've got x squared and x and numbers. Now, if you think back to this equation I wrote up at the top, notice they're all together on one side. That is our goal. We really need to get everything on one side if you ever see and x squared. And I know that's counterintuitive. I know that messes with your head because you just practiced doing your algebra stuff. But you have to know when to do what. That's minus 1x plus 4. My goal is to get 0 on one side. Okay, I really want to get everything moved over to start off with at least so that I can factor it. You can't factor if there's something on one side but not the other. 6 minus 6 becomes 0 over there. Sweet, there's our 0 we were looking for. And then that's minus 2. Okay, good. Now we've got it set up to where we can try and do some of our options. Now remember I said try and factor first. You should try and factor first. Okay, so take a look down here. Quick refresher, remember that factoring is where you do the double bubble, the T-chart. You're trying to get it to break down into two things multiplied together. That's what factoring means. Now obviously the x's go in front. My factors of 2, well, it's only 1 and 2. Those are my only options, so they have to go in there. Let's see if I can make it work. If I can't, then I'm going to have to go to one of my other options, like complete the square or quadratic. But what do I need to do with 1 and 2 to make it a negative 2? Well, that means I need one of each sign, so I can either have positive 1 minus 2, or negative 1 plus 2. Well, which one of those gets me to the negative 1? Okay, well, that would be this option. So I need a positive 1, a negative 2. And remember, this is, oops, sorry, that's not a y. My apologies, that's a 0. Remember, this is review from previous part of the semester. Factoring is stuff we've been doing a lot. Now, you can't just stop there. You have to actually get x by itself, which means each group needs to be set equal to 0. Again, I know this is kind of going back for some review, so if you're struggling or you don't understand what I'm doing, either raise your hand to ask or maybe rewind the video to hear it again. Maybe hearing it twice will help you kind of get the hang of it. So that means one of my answers is x equals negative 1. One of my answers is x equals 2. Now I know I said we can have two solutions, but this is not our final solution. Look at what we have. We have an x equals and an x equals. But go back to your equation. What are we missing? We're missing the y's. So when I say two solutions, that means that I need to have one coordinate and a second coordinate. So I know that one of them is negative 1, and I know the other one, I'll do that in red actually, negative 1 and 2 is the other one. Well, now I have to actually solve for the y, which is why this section takes us a little while to do. So go back up to your original, pick one of your equations. I'm going to go with the first one because that's a lot less work to plug in to solve for y. So y equals 5x plus 6. Okay, we'll plug in negative 1. That's what you just solved for. So it's now 5 times negative 1 plus 6, which means y equals negative 5 plus 6, which means when x equals negative 1, y is equal to positive 1. All right, good. I got one of my points on my graph where the two lines cross. Whew, okay, there's a lot of work. Now I gotta find the second one. I know, lots of work for these type of problems. I did not lie when I said this section would be a little bit more work and a little bit trickier, but it's not impossible to do. You guys are all capable of this, so don't give up if you get frustrated. Ask for help. And then there's the second one. So when x equals 2, y equals 16. Those are the 2 points on my graph where it would actually cross. At least that's what we got based on the math. Let's go up to the top and check our answer. I pull down the box. They cross at negative 1, 1, and 2, 16. Awesome. That is exactly what we found. The blue is the parabola. That's the x squared plus 4x plus 4. The red is the linear. That's the 5x plus 6. So those two graphs cross at exactly those points. Awesome. Pause here if you need to. Rewind if you're not understanding. If you do not understand this example, okay, you need to ask. Or maybe rewind. Or maybe you just need to hear another one. But if you don't get it after that, please ask for help. All right, second one. Again, I've got an x squared in there, which means I really can't do elimination. I know you guys really liked it. It's just way more work and way more options to mess up. Okay, so I'm going to show you guys the substitution route. So it has y by itself, so that means that whole big group is going to replace this y up here because it says y equals all of that. So in place of y up here, I'm putting x squared minus 5x minus 6, and then there's still a plus 5x, and it still equals 3. All right, well, remember what I said in the first example. We're trying to get it to equal 0 because I have an x squared in there. So let's move everything over to the other side, and then we'll deal with it afterwards. What's nice is that negative 5x and that positive 5x actually cancels out. So I'm down to x squared minus 6 equals 3. I'm going to move the 3 over there. So I have x squared minus 9 equals 0. Now, there are two ways you can do this, and some of you might have noticed a different way we can do this besides factoring, but I'm going to show you both. They're both equally mathematically true. It just depends on which way you like better. First way is the factoring way. I'm going to show that one first. You should pay attention for both. That means, how can I factor this so that it breaks up into my double bubble? Remember, if there's nothing in the middle, I can just plop a 0x right in the middle. That's all I did. It was x squared minus 9. All I did was add that. Well, what multiplies to 9 but subtracts to 0? 1 and 9 don't work. 3 and 3 do, though. So 3 and 3, x and x. Okay, well, I need it to be negative 9. So that means I need 1 positive and 1 negative. Okay, we're doing good so far. Make sure I solve for both. So I have x plus 3 equals 0, x minus 3 equals 0, and solve just like we did on the first example. For one of them, x equals negative 3, which some of you might have already picked up on. And then hopefully you can already see what the answer for the second one is. It's x equals positive 3. Goodness gracious. Okay, I'm going to get to the y's in just a second, but I'm going to go back up here real quick and I'm going to show you option number 2, which is solving by square root, which I think personally is a little bit easier if you remember what you're supposed to do. Now, it's got x squared in a number, so why can't I just get x by itself? I don't have x squared plus x, so get x alone. That way I can take the square root. So this gives me x squared equals 9. Well, how do I undo squares? I take the square root. Those are going to cancel out. Remember your phrase, though. I made a root, plus or minus. So it's not just 3, it's plus or minus 3, which is actually what you just got on the left-hand side. X equals positive 3 is one answer. X equals negative 3 is the other answer. That's what plus minus means. It means one of each sign. Okay, so two ways to do it. Doesn't matter which way you pick. No matter what you do, though, excuse me, you have to actually solve for the y still. So go back to your original. Pick a formula. I'm going to use the first one, y plus 5x equals 3, and solve for my y's. So y plus 5x equals 3. All right, well, I got to solve with positive 3 and negative 3. So y plus 5 times positive 3 equals 3. Just going to quick do this because I'm running out of my time. So when it's positive 3, I get negative 12. And then I also have to solve when x is negative 3. So that's y minus 15 equals 3. You guys can rewind and catch up on this if you need to. I'm just running out of time, so I'm going a little bit quicker. So that means your answers are -3, 18 and 3, 12. Check in class for the problems you're supposed to do.